Equations containing a modulus can be solved by algebra or by using graphs. To solve such equations by algebra, there are a number of properties of modulus that we have to investigate. Modulus property 1. If the modulus of x is equal to a, where a is greater than 0, then x is equal to a or x is equal to minus a. We need to learn this off by heart. For example, if the modulus of x is equal to 7, then either x is equal to 7 or x is equal to minus 7. This makes sense. The two numbers that are 7 units from the origin are 7 and minus 7. Solve the equation, the modulus of x plus 3 is equal to 2, by sketching a graph and by algebra. So the graph of y equals the modulus of x plus 3 is v-shaped because of the modulus symbols, and has its apex, which is its minimum point, on the x-axis at minus 3. So if this is plus 3, it has its apex at minus 3. If this was plus 8, it would have its apex at minus 8. If this was minus 10, it would have its apex at plus 10, and so on. To solve the equation, we can draw this graph and the line y equals 2. The solutions are the x-coordinates of the points of intersection of the graph and the line. So basically, we take our original modulus graph, which has a minimum point at 0, 0, and we just move it 1, 2, 3 steps to the left to find our new apex. Move it 3 steps to the left. And then we plot all the other points the same. So we just go in a diagonal line to the right and in a diagonal line to the left of our apex minus 3. Next, we're going to draw on the line y equals 2. So we go to 2 on our y-axis, draw a line straight across. And the solutions are going to be the x-coordinates of the points of intersection. So clearly, here's a point of intersection. So we drop a perpendicular and we end up at minus 5 on the x-axis. And here's another point of intersection. We drop a perpendicular. We end up at minus 1 on the x-axis. From the graph, the solutions are x equals minus 5 and x equals minus 1. Now we're going to solve by algebra. So by property 1, this is property 1 here, if the modulus of x plus 3 is equal to 2, then we have x plus 3 is equal to positive 2 or x plus 3 is equal to minus 2. So we're going to have 2 minus 3 is minus 1 and minus 2 minus 3 is minus 5. So we get the same answers, minus 5 and minus 1. Modulus property 2. If the modulus of x is equal to modulus of y, then x equals y or x equals minus y. If two numbers, x and y, have the same modulus, then they are the same distance from the origin. This can only be true if the two numbers are equal or one is the negative of the other. For example, the modulus of 3 is equal to the modulus of 3 and the modulus of 3 is equal to the modulus of minus 3. Solve for x is an element of the real number set. The modulus of 2x minus 1 is equal to the modulus of x plus 2. So by property 2, we have the modulus of 2x minus 1 is equal to the modulus of x plus 2. So we have 2x minus 1 is equal to x plus 2, or 2x minus 1 is equal to minus x plus 2. Make sure you use brackets here. So let's just take our equation on the left-hand side first of all. 2x minus 1 is equal to x plus 2. So bringing the minus 1 over the equal sign, it becomes plus 1. So we get 2x is equal to x plus 3. Bringing the x over the equal sign, we get minus x. 2x minus x is x. So x is equal to 3. Now let's have a look at the second equation. 2x minus 1 is equal to minus times x plus 2. Make sure you have brackets. We bring down the 2x, bring down the minus 1 and the equals. Minus by x is minus x, minus by 2 is minus 2. So we have 2x minus 1 is equal to minus x minus 2. Bring the minus 1 over the equal sign, it becomes plus 1. And minus 2 plus 1 is minus 1. And bring the minus x over the equal sign, it becomes plus x. 2x plus x is 3x. So get 3x is equal to minus 1. So get x is equal to minus 1 over 3. And next we have modulus property 3. So the modulus of x squared is equal to x squared, i.e. when we square modulus, we can just remove the modulus. The reason for this is that when we square a number, whether it's positive or negative to begin with, the outcome will always be positive. Thus, we no longer need the modulus symbol. Example, find the value of m, which is an element of the real number set, for which the modulus of m plus 1 is equal to the square root of m squared plus 5. So because of the square root, we will square both sides and remove the modulus. So the reason we're squaring the modulus is because we want to get rid of the square root. So we have to square both sides in order to get rid of the square root. So we have the modulus of m plus 1 is equal to the square root of m squared plus 5. Squaring both sides gives us m plus 1 squared, and removing the modulus symbol, we don't need that anymore, which is equal to the square root of m squared plus 5. All of this has brackets around it and is squared. M plus 1 times m plus 1 gives us m squared plus 2m plus 1. And squaring a square root, they just cancel out and leave what's underneath the square root. So we bring down the m squared and the plus 5. Then we solve. So the m squareds can cancel out on either side. So we have 2m plus 1 is equal to 5, bringing the 1 over the equal sign. It becomes minus 1. 5 minus 1 is 4, so 2m is equal to 4. Dividing across by 2, m is equal to 2.